Hi, this is Victor Morganti from Fact Engine. Today we're going to be looking at metadata storytelling inside the Boston conceptual modeling software. We've got Boston open in front of us, and we've got a couple of models open in the Model Explorer on the left hand side, a cinema bookings model and a university model. But first let me tell you a little bit about metadata storytelling. So metadata storytelling is a term that Fact Engine is using to describe the ability to tell the story about a model using artificial intelligence and a virtual business analyst. So we can imagine where I'm a new person to an organization, and this is the first time I'm looking at these models, and I don't understand the purpose of these models or what the models are about. I'm using Boston over the internet, and if I press F11 now, you can see that I'm inside a browser. So this is the address bar up here of the browser, this is the tab, and I could be in the United States or India or Europe and working collaboratively in a team and working on a conceptual modeling project. I've just been introduced to the project, I've just come across a conceptual model that I want to understand. And of course there's various ways that I can find out about the model. I can open the pages and look at them. I can start to step through the conceptual model itself, or I can go to the Virtual Business Analyst in Boston, and I can, in this text box down the bottom, type in provide a 100-word high-level overview of this model and its purpose. So that's going to get farmed out to an artificial intelligence to go away and analyze the model and come back with a narrative, so to do the metadata storytelling on the model. This is the description of the model that's come back. What I'm going to do is I'm going to farm that out to a new service that we're using, which does high quality natural language. So I'll just let that come back with the description of the model.
The cinema bookings model is a structured representation of a cinema booking system. It includes entities such as person, film, cinema, session, and booking. The model captures relationships between these entities, such as a person liking a film, a person booking a session, and a session showing a film at a cinema. It also includes details like the seat in a section and row, and the cinema hosting the session. The model is designed to manage and track cinema bookings, including the preferences of the customers, the films being shown, and the details of the cinema layout.
And that's 100% right. So if I open a property graph schema view of the model, indeed it is about people making bookings for sessions to watch films at a cinema, and it provides the structure of the cinema, so the cinema layout. So a cinema has rows, and seats are in those rows, and seats are in sections. So it's a cinema booking database. We can have a look at the entity relationship diagram view for that model, and similarly it provides the same information. So person booking and a relationship between a seat and booking. So a booking can have many seats and a seat can have many bookings, but it's all about sessions. So a person making a booking for a session to watch a film at a cinema, etc. Now this is possible in Boston because Boston uses object role modeling, and if we go to the glossary view of the model and click say on cinema, because we're using object role modeling, we have a natural language semantic view of the model. So we can read cinema possibly contains more than one row. Row is in one cinema. Each cinema has one cinema ID. Each cinema has one cinema name uniquely identifies cinema, and of course cinema possibly hosts more than one session, so it's all about sessions. If I click on session and have a look at its narrative, it says session is where film is showing at date time at cinema. So if I pass all of that natural language to a large language model, which naturally processes and analyzes and performs logical functions over natural language, the large language model can provide a descriptive narrative of our database back to us in natural language. So that's quite a simple model. Let's have a look at a more detailed model. So this is a university model. It's quite a large model. If I open the Virtual Analyst, so provide me a 100-word high-level overview of this model and its purpose. I just had that in my clipboard, so I'll just hit go on that. That's being farmed out to a large language model, which will come back with a metadata storytelling narrative of the actual model. So let's highlight that and farm that out to another AI to generate some very natural sounding language to describe the model.
This model represents a university's organizational and operational structure. It includes entities like buildings, courses, faculties, lecturers, students, and units, each identified by unique IDs. It also includes relationships between these entities, such as a lecturer coordinating a unit or a building housing a room. The model also captures timetable structures, semester structures, and room styles. The purpose of this model is to provide a comprehensive view of the university's operations, from course scheduling to faculty assignments, enabling efficient management and planning. It also facilitates analysis and decision-making by providing a structured view of the university's data.
And that's 100% right. So this particular model is about allowing us to do timetable bookings and scheduling for a university. So where a lecturer in a time slot in a room hosts a class or provides a lecture, and for a faculty, and where if we look at lecturer, for instance, indeed it does provide information about allocation, so where a lecturer is in a school and where they have a position and where they're in a faculty, and of course it provides information on such things as courses and majors, etc., such that we've got a high-level view of the course structure of a database, of a university, so that the person using the database can use all of that information to provide scheduling information for lecturers and tutors for classes in rooms, etc. So that's a high-level view of metadata storytelling in the Boston conceptual modeling software. This is available on a desktop or over an intranet or extranet. Again, if I press F11, we can see that I'm in a browser. This is the browser tab. Press F11 again, and we've got a full view of Boston, where I could be using Boston anywhere in the world collaboratively to work on conceptual models. So thanks for watching. I hope you enjoyed the video. I look forward to speaking with you soon. Thank you for watching. I hope you enjoyed the video. I'm Victor Morgani from FactEngine. FactEngine provides consulting on knowledge graphs, object role modeling, property graph schemas, and relational models. And of course, FactEngine is the author of the world-leading Boston conceptual modeling software. Thanks again. I look forward to speaking with you soon.